There are many technicians who prefer to diagnose electrical circuits with a test lamp, but there are certain situations where the test lamp can give you false indications leading to incorrect component replacement. In this example circuit we have a headlamp bulb, a 12-volt battery, and a switch. When we turn the switch on, we can see that the circuit is broken. The headlamp does not illuminate. Many times a technician will begin testing at the component. They'll unplug the component and probe across the terminals with the test light. When you turn the switch on, you see that the test lamp illuminates. This would give the technician the false impression that the circuit is okay and that the bulb is faulty. After replacing the bulb and re-energizing the circuit, we can see that the bulb still does not illuminate. So what's going on in this particular circuit is I have inserted this 15 ohm resistor that simulates a poor connection. And that poor connection is causing the headlamp to be inoperative. We can see when we bypass our simulated poor connection, the bulb works fine. So what's going on? Why does the test light illuminate but the bulb does not? Well, the voltage divider formula can help us understand what's going on here. This formula is derived directly from Ohm's law. Vx is the voltage across the component terminals. Vs is the source voltage. Rx is the resistance through the component. And RT is the sum of all the resistance in the circuit. When we're probing the circuit with the test light, we have a test light resistance of 112 ohms, and our poor connection, our simulated poor connection, is 15 ohms. When we plug these values into the formula, we get 12.6 multiplied by 112 over 112 plus 15, giving us 11.6 volts. This is plenty of voltage to illuminate the test light. However, when the headlamp bulb is connected to the circuit, we have a resistance of 2.85 ohms, and again our simulated poor connection is 15 ohms. Plugging these values in, we get 12.6 multiplied by 2.85 ohms over 2.85 plus 15, which results in a voltage across the bulb of only 2 volts. This is not nearly enough voltage to illuminate this headlamp bulb. So, in order to avoid falling into this trap, we should test the circuit with a voltmeter. If we begin at the bulb, attaching the leads in parallel across the bulb terminals, turning the switch on, and reading the displayed voltage, we can see we clearly do not have enough voltage to illuminate the bulb. We know we have 12 volts, 12.6 volts in the battery, so we must be dropping 12.6 volts across this circuit. Again, we can use the voltmeter to measure voltage drops across different sections of the circuit to locate the source of the resistance. You can see across this positive battery voltage circuit we have a very low voltage drop, indicating that there is very little resistance. However, when we measure voltage drop across the battery negative circuit, we can see we have 12.3 volts. So our resistance must be between this terminal and the negative battery terminal. We can section off this circuit in order to locate the source of the resistance. In this case, it's our simulated poor connection, which is getting very hot. It may seem counterintuitive to a beginner that they should be using the voltmeter, which is much more complicated than the test light. The test light is so simple to use. That's why many beginners like to use it. But as we can see, there are traps that the beginner can fall into when using the test light. Therefore, it's always a good idea for the beginner to always use the voltmeter for circuit testing.